meaning that the medium that we use to transmit data, right? The medium to transmit data. Okay, when we said media, what is pop up in your mind? Anything, anybody? Storage media. What is storage media? Anybody? Before we go further,
USB.
USB. Okay, yes. Hard disk. What else? So, transmission media is a media. It could be a guided media, unguided media. It could be a physical media, or wireless, wired or wireless. Okay, wired or wireless. Wireless could be radio, could be infrared, could be what else? Um, Wi-Fi. Yes, Wi-Fi is an example of um, wireless media. Okay, in what layer? In what layer? Remember the 5 layer or 7 layer in your OSI? It concerned with anybody? Hello? Anybody there?
Yes, doctor.
Yeah. In what layer? Remember the 7 layers of the TCP/IP and the 5 layers of the TCP/IP? Anybody? Anybody? In what layer? Okay. After Hari Raya forgot everything.
Banyak makan lemang, doktor.
Yes.
Okay. Remember the lowest layer? What is the lowest layer? Promise. I promise you. You got this in exam. You will die. You meet me next week. Next week. Next sem again. Okay. There's one student. Actually, two students from last year. They have attended their LI, but they still need to come to the campus to resit for the exam. Hopefully, they pass. Okay, they pass because they're working and they're studying. They're working and they're studying. Even when they're studying, they fail. So I wish all the best for them. So I hope you are not one of them. Okay, what layer? Come on. Only 5 layers. The lowest layers you hardly remember.
Physical layer.
Yes, sir.
Okay, if you say physical layer, it's not true, but it concerns with physical layer. Okay, it concerns with physical layer. So if physical layer is layer 1, we can say this is layer 0. Okay, this layer 0. All right. This physical layer, they are controlling and they're receiving the input from this physical meaning that uh, it could be a guided media or unguided media. The guided media, the guided media meaning that it could be a copper wire or twisted pair or coax, or it could be this is very common, the fiber optic. Okay, the fiber optic. If you have Wi-Fi at home, the last mile or the last that your TV or your connection are received from the fiber optic. Okay, so as you know, the computers and other devices, your gadgets, are receiving signal to represent data. These signals are transmitted in the form of electromagnetic energy. Okay, electromagnetic energy, which is propagated through transmission media. This data represented as signal. Okay, signal that move through uh, the twisted pair, okay, or electric voltage in your copper. If you notice that the computer that you're using, the desktop especially, there's a Ethernet cable behind the CPU, and it is attached to the RJ45 female. Okay, female, male. We'll discuss later on. Um, it could be a radio wave, microwave. Actually, the microwave is a radio wave as well, but this a micro radio wave, infrared, and plus this is not covered in your uh, syllabus, but the latest technology we have the laser as media, transmission media. All right, this is physical layer. This is the last layer, the last or the first layer, the first layer actually, because you are counting it from bottom up from the lowest layer. Okay, physical layer, the sender and receiver. Okay, we have guided and unguided, or wireless and wired, wireless and wired. In data communication, in data communication, we use both this wired and wireless. Okay, both wireless. Some are wireless, some are wired. Okay, the wired transmission media. We have the twisted pair, the coaxial cable, fiber optic, and the unguided. Yes, of course, there has air or this one, microwave, infrared, and laser. Okay, the guided media first. Okay, the guided media, the twisted pair cable, um, the coax cable, fiber optic cable. Okay, okay, how it looks like. This is a twisted pair. Twisted pair. We this is the copper wire or cable insulated by the plastic covered insulation. Insulation. And okay, we have the UTP and STP. UTP being an unshielded twisted pair, unshielded twisted pair, and shielded twisted pair. Okay, shielded twisted pair. Shielded means that you have this metal shield around the copper and plastic covered. Okay, metal shield. Why we have the metal shield here? We need this metal shield to reduce noise noise from affecting the signal. Okay, in real application they may have bulk of twisted pair here, and every twisted pair they have the noise, electromagnetic noise signal the adjacent from the adjacent cable, right? This, So this metal should help to reduce, if not to 100%, to reduce 100%, at least the noise can be reduced. Okay, this is more common nowadays than this one. Okay, so if you look into the desktop, you need notice that this Ethernet cable here using the twisted pair. Usually shielded twisted pair and Ethernet port attached to this. You know what is this, right? Apa benda ni? Anybody? Anybody? No idea. No idea. This is the first time in your life seeing this kind of creature.
No, sir, no.
So what is it? Alien.
RJ45.
RJ45, yes. What this one?
Wi-Fi. Wi-Fi
Okay.
adapter.
Adapter. What adapter? Network adapter. Okay. Um, example. Okay. Why 8? Why not 10? Okay. This is RJ45 female. RJ45 male. Okay. What is RJ? Registered jack. Okay. Registered jack 45. So you know how to distinguish between male and female, right? Because you yourself are female or male. Okay, that is a twisted pair. Okay. Now the coax. The guided media still coax. Okay, this is coax looks like. This one RG6 coax cable. Where did you used to come across this cable? Never. This is the first time in your life.
Astro.
Astro, yeah.
Antenna.
Yeah. Coax. Astro antenna, cable TV. Last time we are using the Astro still using this. Now we are moving to the digital TV
Digital.
already.
My
Yeah,
TV.
digital TV. Yes, but previously that using the not digital TV, the analog TV as well are using this. Okay, because it transmitted the signal used to media to transmit the signal as well. Okay, it also used in an Ethernet apart from the twisted pair. It also used in a coax Ethernet. Okay, but the Ethernet they call it as a thin Ethernet and thick Ethernet. Okay, thick Ethernet cable, thin Ethernet and Ethernet cable. It carries much bigger, faster data than the twisted pair. Okay, this is the structure. We have the inner conductor and outer conductor. Okay, so both conductor, shield, and the insulation, and this also insulator, and the outer coverage.
Okay. And okay, there are many types. This is RG6. Okay, done. Another one, the guided media fiber optic. Okay, fiber optic is one of the mostly used uh, cable, guided media cable for LAN, for home use, internet home use, to the last mile, and as well as for the backbone. Okay, the backbone. You know backbone, the highway. Okay, imagine that you have a small road that reach to your house. Okay, the small road or the small street, they are attached to the bigger street and bigger road and highway and super highway. Or those super highway are mainly use this fiber optic technology. Okay, fiber optic technology. Okay, we have different mode, multi-mode and single mode. Multi-mode and single mode. In multi-mode, we have step index and graded index. So how it looks like? This is how it looks like. Okay, I want you to observe this slide and tell me which is the base mode for sending data and why. Okay, take a minute. Anyone?
Multi-mode, sir.
Again?
Multi-mode.
Multi-mode. Okay, there are two multi-mode. Which one?
The first one.
Not really. Okay. Actually, okay. I give you the clue. This is the source, the source, the source. But look at this output when the beam. Actually, what is inside the fiber optic? If you can cut it across, potong dua, you will see a light beam, very colorful, like a rainbow, very, very, very colorful. If I point it to the wall, it looks like what I can say, the disco, the pop light, what I don't know. Okay, okay, a rainbow. Okay, uh, this is how the the output when it reaches the destination. Okay, by seeing this, which is the signal is that is more intact? Mana signal yang lebih intact, lebih lebih less attenuation? Remember attenuation I mentioned last week about attenuation. mana dia punya ni. Okay, say this is 0, 1, 0, 1. Okay, this is 0, 1, 0. Okay, this is look like. Which of these output are more intact among all the single mode? Okay, yes, correct. Okay, single mode. Okay, why single mode? Okay, imagine you're walking in the highway or in the street, and you are stopping at every everywhere, at the R&R, at the coffee shop, or anywhere to pee or whatever. Okay, compared to this straight line without stopping. Okay, without stopping, you will reach the destination much faster. Okay, that is why uh, the single mode is the fastest that is used for the by the telco, and in a single mode. Okay, single mode, this is multi-mode graded index. Okay, let's see one by one. Okay, single mode fiber optic cable has a smallest diametral core that allows only one mode of light propagate. One light. Okay, as I mentioned, it's a beam light. Okay, beam light. Because of this, the number of reflection created as the light passes through the core decreases, lowering attenuation. Remember attenuation when the signal is getting weaker and weaker, and creating ability for the signal to travel faster and further and farther, longer. Okay, and is typically used by the telco, the DG, the Cellcom, what else? The Telecom, Maxis for their backbone, and CAT TV companies and universities. Okay, if you're allowed to dig, of course you're not allowed to dig in the along the street to the campus. There's a fiber optic underground there. Okay, underground there. I'm not sure what mode. I never dig it myself. Okay, multi-mode fiber optic. Multi-mode, okay. This multi-mode. We have two types of multi-mode, step index and graded index. It has large diametral core, allows multiple modes of light to propagate. Yes, multi-mode, multi-light. 1, 2, 3. 1, 2. Refers to the fact that numerous modes of light rays beams are carried simultaneously through the waveguide. Because of this, the number of light reflections created as the passes through the core increases, creating the ability to more data to pass through the core at a given time. Okay, more data, but doesn't mean that it is fastest data, right? And because of the high dispersion mean that they are dispersed, okay, dispersed, or deflect. And attenuation rate with this type of fiber, the quality of signal is reduced over long distances. Okay, long distances. Usually they have the repeater, or yes, they have the repeater. Uh, and this application typically used for short distances, for audio and video in within LAN. within LAN. So you can assume that we also have this one in our campus area. Okay, multi-mode step index. This is step index. They call it step because step like a step. Density of the core remains constant from center to the edges, so the beams move in a straight line until it reaches the interface of the core and the cladding. Straight line, straight line, straight line. At the interface, there's abrupt change. Okay, interface means that this surface. Okay, this surface. At the surface, there is abrupt change to a lower density that alters the angle of the beam's motion. Alters the angle of the beam motion suddenness. Okay, it refers to the suddenness of this change. Right? Ini sudah kan tadi. Okay, graded index. Core has density. That is why light moves in straight line. Okay. Graded index. The step index, graded index. Okay, graded. This kind of fiber decrease the distortion of signal through the cable. The word index refers to refraction or bias. This is related to density. So the graded index fiber is one of varying density. Density is the highest at the center of the core and decreases gradually to lowest at the edge. Okay, this is a graded index multimode, like a wave. Okay. Okay, covered all the guided media. No, now the guided, unguided media or radio, wireless. Any question before we move on? Ada soalan sebelum kita next?
Tiada, sir.
Alright. Good. Okay, guided media, wireless, radio waves, microwaves, infrared, laser. Okay. I'm not covering this one. Okay. Just for your info. Okay. This is example of radio wave. You turn on your radio, you have option to turn the channel to FM or AM. Okay, what's the difference between FM and AM? Not the DJ, not the music, not the channel. Okay, the AM means that amplitude modulation. They are modulating the signal based on the amplitude. Okay, amplitude AM. And FM is a frequency modulation. The frequency modulation. They're encoding the signals based on the frequency. Okay, the frequency. Usually you have this kind of frequency in FM radio. This is AM radio. All right, the unguided media, they don't have physical medium as a copper or fiber optic or coax or any means. they're using the air to transport the electromagnetic waves without any physical conductor, and broadcast. Okay, the term broadcast, we have unicast, we have multicast. Later on, we discuss what is multicast, unicast. Signals are normally broadcast through air. Okay, sorry, I'm staying near the airport. Broadcast to air and available to anyone. You have the receiver to receive the signal. Okay. In radio, you have the receiver. Of course, you have receiver, but the DJ have the transmitter. Okay, they transmit the signals and you receive the data, the signals. Okay. All right. Okay. The spectrum, the spectrum. The radio wave, the radio wave. The range is between 3 kilohertz to 3,000 gigahertz. Okay. Actually, when it reaches 1 gigahertz to 300 gigahertz, we consider it is a microwave already, not a normal radio wave, microwave. It's microwave oven that you have in your kitchen. Okay, microwave. They call it micro because the wave is very tiny and it has high frequency. Okay, micro high frequency. And you also have the infrared and light wave. Okay, we'll discuss it later on this one. Okay, propagation methods, how the signals are propagated. We have ionosphere here around the globe in the earth. Ionosphere. Okay, look at this. Okay. This is ozone layer, right? Have you ever heard the ozone layer? What pop up in your mind when people say ozone? Kamu sudah dengar kan?
Atmosfera.
Yes, atmosphere. What has to do with atmosphere? All the scientists, the media are talking about the ozone layer because of the what? Pollution, often burning.
Global warming.
Global warming, yes, good. Because they are thickening. No, they are already thinning, not thickening, thin, getting thinner and thinner day by day, and many of those rays, which not supposedly penetrated the atmosphere, reach the surface of the earth, and the earth are getting warmer day by day. Okay, never mind. This has not covered in your syllabus. Not ask you. Okay, the ionosphere concerns with this one. Okay, one. Actually, the skies are layered. You know, layered. There's in the Quran they said there are 7 layers. 7 lapisan langit, 7 lapisan bumi. All right, never mind. Ionosphere is in this area. Ionosphere in this area. All right. Okay. We start with this line of sight propagation. Okay, very light, 300 megahertz. It requires line of sight propagation. Okay, point to point. If there's a building or mountain or hill at the center that blocking these signals, the signal cannot get through. Okay, so line of sight propagation above 300 megahertz. Usually for high frequency radio signals transmitted in a straight line directly from one aerial or to the other aerial, one receiver to another receiver, transmitter and receiver facing each other. All right, they don't concern with this layer. Okay, but this one, yes. Okay, this one. This is high frequency radio. This is very high frequency radio. This higher frequency radio, they propagate upward into the ionosphere and reflected back to Earth, to the transmitter. So this is not necessarily, of course, they don't require line of sight. Line of sight. Okay, this is normal radio propagation. Radio waves travels through lowest portion atmosphere near to Earth. Okay, this is directional. This is we call it omnidirectional. 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 To find out further what is omnidirectional. All right. Again, the ozone layer, and then this one. Okay. Band meaning that the frequency range, the hertz propagation application. We have very low frequency radio, very low frequency radio, like this one, 3 to 300 kilohertz, long radio navigation, low frequency radio, mid-range or middle frequency, mid-range radio, AM radio, okay, AM radio, high frequency radio, okay, used for aircraft communication, ship, and military as well, and VHF, very high frequency. That is what we have for our radio, FM radio. But even the FM radio has also been digitized, right? And UHF, ultra high frequency, SO, paging, satellite, line of sight. Okay. The internet are using this line of sight as well. Line of sight for the backbone. This is super high frequency satellite communication. And we have extremely high frequency. Also requires line of sight, long range radio navigation. We have radio wave, microwave, infrared. Radio wave, microwave. Okay, actually this is a radio wave as well, but they distinguish it because of the frequency, the micro frequency, because see, giga. You know giga, how many zeros behind it? Remember? All right, the applications. The wavelength. Okay. Okay, start from here lah. Okay. Okay, this is you know this signal. Okay, there has a property, the what do you call it? Radioactive. Okay, radioactive properties. Okay, using if you know the chemotherapy, those who got cancer, they have to undergo this treatment. They will kill the tumor. Okay, the tumor will kill and at least will make it to remove the tumor. At the same time, it kills other cells as well. Okay, God forbid. Okay, X-rays is also they use to uh, it's actually a radio wave as well. They have the radiation in. That's why they can penetrate your cells, and usually when they are uh, switch on the X-rays, they're not allowed other than the patient inside the room because it has affect your cells as well. Those who are pregnant are not recommended to got this X-ray view inside your bodies and objects. And ultraviolet absorbed by skin used in fluorescent tubes. Visible light. This is the visible light you can see. Infrared transmitted heat from fires radiates. Okay, microwave, and this is a radio broadcast. Okay, the higher the frequency, and the higher the frequency is, the more harmful for your health. More harmful, not harmful, it's dangerous. Okay, it has radioactive properties. All right, radio, microwave, infrared, visible, ultraviolet, X-ray, gamma rays. What else? Okay, this is omnidirectional antenna. If you are living here, they will broadcast in all directions. You can receive it anywhere where the signal can cover. You can cover. This is omnidirectional radio. Okay, radio waves are used for multicast communication. Omnidirectional, it propagates to all directions. STV, radio. Okay. Okay, that is radio waves. Now the microwave used for unicast communications, used for wireless LAN and microwaves. Okay, if you notice that microwave, they got kind of transmitter and receiver like a frying pan. Nampak tu macam kuali kan? Perasan tak? Okay, that the frying pan look like a receiver. They will collect the signals, but they need to be face to face, bidirectional, within line of sight. Okay, if something in the middle, building or hilly areas or mountainous areas or thick jungle, that blocking the signals, that the signals or the waves might be affected. Okay, might be affected. That is unicast. Okay, communication. Okay, same goes to the satellite as well. Infrared signals. Anyone can give me one device? Infrared signals. You see it in your everywhere.
Remote TV.
Remote TV, yes. Okay, ada lagi yang lain? scanner. Ialah remote TV, remote aircon apa lagi, remote kereta apa lagi. Scanner, thermal scanner, okay, thermal scanner. In military technology, they have thermal scanner, or which they can see any movement from a very far distance because they are detecting the heat from your body, meaning that everything moving and like a human or animals, they can detect. Okay, that is the application of the infrared. But they cannot penetrate wall. Okay, they can't penetrate wall. You experiment, you close your door, and you try to switch the channel from your room to the living room. Let's see how it works. Okay, end of class. Any question? Okay, I assume that you understand well. If you have no question, I want to discuss with you your assignment project.
Yes.
Okay, let's look at your item. Item, item, item. Okay, I have divided you to your respective group. So please refer to this ITEL to find out which group that you belong to. Okay. Okay, the question is asking you about the issues in Sabah, especially in remote areas. Okay, remote areas. Most of the Sabah's population, they don't have access to broadband. Okay, access to broadband. So these people are very much affected economically, in education, in social, and disconnected from the rest of the world. Okay. So this is your task. That is the problem statement. Propose a practical and reliable solution. Okay, I have covered so far about the transmission media, the technology, but you need to go further to research further. What are the available technology out there that might possible, but you might think possible to solve this issue? Okay, so I bold this design and implementation model, yeah. And this is not real. I'm not asking you to propose the technology in place, but at least you have the conceptual idea and how the technology will solve the broadband access for those rural people, okay, the rural community. Okay, okay. I give you example. I give you example. We just mentioned about the fiber optic. Okay, fiber optic. A fiber optic is the most widely used infra, and this is the solution for
the broadband. Okay, the solution for the broadband. But most telcos, most telcos are not willing to provide or the infrastructure for those people living in the rural areas. Why? Why? Because understanding the population, rural population, are scarce. Maybe there are only 100 or 1,000, less than 1,000 people living in not in a centered location. So this telco, Maxis, Telco, DG, whatever, they don't think that it is profitable to provide access to these people. Not profitable. No money, no talk. Okay, no money, no talk. So the issue remain out there for the government to tackle. Okay, so if you this is the first thing you need to do. The first thing you need to do is Google, not Google. Try to Google Scholar at least, or find the journal or journal, research journal, research article, not simply a berita harian ke atau utusan ke, unless you just want to get the issue. Okay, try to get the scholarly article about how to solve this problem. Okay, how to solve this problem. Actually, even in those countries like in US, in UK, is Western Europe, okay, the most advanced country in the Western Europe, they also facing the similar issue for their uh, people living in far distance in rural areas, okay, in rural areas. So there is a solution. So I want you to adapt or adopt those solutions that think whether it is possible to implement to tackle the broadband access for the rural access. Okay, particularly in Sabah. Any question? Ada soalan? About group, about the assignment question?